Hello students. Hello and welcome to this video. In this video, we will solve question number 221 to 230 of binomial theorems. The link to download the PDFs will be in description, as well as at the end I will show you how you can download the PDFs or read online and maintain an updated copy. Also I will show you at the end that how we can join my question answer website, where you can come and ask questions or give answers. And let's build a community together. So without further ado, let's get started. Question 221 says that show that C3 plus C7 plus C11 and so on is equal to 1 by 2 times 2 to the power n minus 1 minus 2 to the power n minus 2 sine n pi by 4. So we know that we know the expansion of 1 plus x to the power n, and we know what happens when we put x is equal to 1 and minus 1. So we'll get these two expressions, and then we add and subtract. We arrive at C0 plus C2 plus C4 and so on is equal to 2 to the power n minus 1, and C1 plus C3 plus C5 and so on is equal to 2 to the power n minus 1. Now we put x is equal to I here. We get C0 minus C2 plus C4 minus C6 and so on plus I times C1 minus C3 plus C5 minus C7 is equal to 2 to the power n upon 2 cos n pi by 4 plus I sin n pi by 4. Equating the imaginary part, we get C1 minus C3 plus C5 minus C7 and so on is equal to 2 to the power n upon 2 sine n pi by 4, which implies that C3 plus C7 plus C11 is equal to 1 by 2 to the power n minus 1 minus 2 to the power n by 2 sine n pi by 4. Question 222 says that if 1 plus x plus 2x squared to the power 20 is equal to a0 plus a1x plus a2x squared and so on up to a40 x to the power 40, then find the value of a0 plus a2 plus a4 and so on up to a to the power 38. So we put x is equal to 1, we get a0 plus a1 plus a2 up to a40 is equal to 4 to the power 20, that is 2 to the power 40. We put x is equal to minus 1, we get a0 minus a1 plus a2 minus a3 and so on up to a40 is equal to 2 to the power 20. So we add it. Adding gives us a0 plus a2 plus a4 and up to a40 is equal to 2 to the power 39 plus 2 to the power 19. So we have got three such equations, and clearly we have a40 is equal to 2 to the power 20 is equal to a0 plus a2 plus a4 up to 8 to the power 38 is equal to 2 to the power 39 plus 2 to the power 19 minus 2 to the power 20, which is equal to 2 to the power 19 times 2 to the power 20 minus 1. Question 223 says that if 1 plus x plus 2x squared to the power 20 is equal to a0 plus a1 plus a1x plus a2x squared to a40 to the power x to the power 40, then find the value of a1 plus a3 plus a5 up to a37. So similarly, we put x is equal to 1 and x is equal to minus 1, and then we subtract, we get a1 plus a3 plus a5 up to a39 is equal to 2 to the power 40 minus 2 to the power 20. Now a39 is coefficient of x to the power 39 in 1 plus x plus x to x squared to the power 20. That is coefficient of x to the power 39 in 1 plus x times 1 plus x to the power 20, which is equal to 20c20 x to the power 20 1 plus 2x to the power 20. That is coefficient of 19 in 1 plus x to 2x to the power 20, that is 20 times 2 to the power 19, and thus a1 plus a3 plus a5 plus up to a37 is equal to 2 to the power 19 times 2 to the power 20 minus 21. Okay. So one more thing I wanted to say is, if you wanted to understand how this a40 is equal to 2 to the power 20, then you see that if you square this polynomial, you get 2 to the power 2 x to the power 4, and then next, if you cube it, it will become 2 to the power 3 x to the power 6. Certainly this power will be 2 to the power 20. Okay, I did not explain that. Okay. Question 224 says that show that c1 minus c2 upon 2 plus c3 upon 3 and so on up to minus 1 to the power n cn plus 1 upon n times n minus 1 plus 2 upon n minus 1 times n minus 2 and so on up to n minus 2 upon 2 into 3 is equal to n plus 1 upon 2. So we have this expression for 1 minus x to the power n, and we integrate it. No, we did not integrate it yet. So we have this expression and we divide by x. We bring 1 minus x to the power n this side, and we take all these terms except 1 to the right hand side, and then divide by x. We get c1 minus c2x plus c3x square and so on up to minus 1 to the power n minus 1 cn x to the power n minus 1 is equal to 1 minus x to the power n upon x. Now integrate between limits 0 and 1, and we arrive at c1x minus c2 times x square upon 2 plus c3 times x cubed upon 3, and so on within limits 0 and 1, where we integrate between 0 and 1 the term 1 minus x to the power n to the power upon x dx. Now we integrate this, we get z is equal to 1 minus x, so it becomes 1 minus z to the power n upon 1 minus z dz. Now we integrate this. So this is nothing but 1 plus z square up to z to the power n. This should be minus 1, n to the power minus 1 dz. So upon integration between limits from 0 and 1, it becomes 1 plus 1 upon 2 plus 1 upon 3 plus up to 1 upon n. Now 1 upon n times n minus 1 plus 1 upon n is equal to n upon n minus 1. And 2 upon n minus 1 times n minus 2 plus 1 upon n minus 1 is equal to n upon n minus 1 times n minus 2. And so on till n minus 2 upon 2 into 3 plus 1 into 3 is equal to n upon 2 into 3. We will have 1.5 left. So n upon n minus 1 is equal to n times 1 upon n minus 1 minus 1 upon n, and n upon n minus 1 into n minus 2 is equal to n times 1 upon n minus 2 minus 1 upon n minus 1, and so on. So the sum would be n by 2 minus n upon n plus 1 plus half, which is equal to n plus 1 upon 2. Question 225 says that show that sigma where 0 less than equal to I less than j, sigma 0 less than j less than equal to n less than equal to j less than equal to n, I upon ci plus j upon cj is equal to n square upon 2 sigma r is equal to 0 to n 1 upon cr. So we have to prove this. We let s is equal to given left hand side. We replace I by n minus I and j by n minus j. So it becomes sigma 0 less than equal to I less than j, sigma 0 less than equal to j less than equal to n minus I upon ci plus n minus j upon cj. Thus 2s is equal to n times sigma, both sigmas, times 1 upon ci plus 1 upon cj. Now s is equal to n upon 2 sigma r is equal to 0 to n minus 1 n minus r upon cr plus sigma r is equal to 1 r upon cr, which is equal to n upon 2 sigma n upon cr r is equal to 0 to n, is equal to n square upon 2 sigma r is equal to 0 to n 1 upon cr. Question 226 says that sigma, same sigmas are there, and the term which we have to consider for sum is I into j into ci into cj is equal to n square times 2 to the power n 2n minus 3 minus 1 upon 2. This should be 2n minus 2 here, 2n minus 2c, 2n minus 1. So we have the sigma, we separate out I and j, we can write I into n upon I, c n minus 1 upon I minus 1, and j into n upon j, n minus 1 c j minus 1, which is equal to n square upon 2, 2 to the power 2n minus 1 minus 2n minus 1 cn minus 1 using the results we have obtained earlier, and thus we have the required sum. Question 227 says let's prove that c1 minus 1 plus 1 upon 2 c2 plus 1 plus 1 plus 1 plus 1 upon 2 plus 1 upon 3 c3, and so on up to minus 1 to the power n 1 plus 1 upon 2 plus so on up to 1 plus n cn is equal to 1 upon n. So here the Rx term is minus 1 to the power R minus 1, 1 plus 1 upon 2 plus 1 upon 3, and so on up to 1 upon R and CR. So we write this sum as 1 minus x to the power R upon 1 minus x for this 1 plus x square to x to the power R minus 1. So this is a geometric progression and we write this is equal to this. Now 1 minus x sigma R is equal to 1 to n minus 1 to the power R minus 1 CR minus 1 to the power R minus 1 x to the power R and CR is equal to 1 minus 1 upon 1 minus x is equal to, now these sums we have derived earlier. So it is, if we do all that, we will have 1 minus x to the power n minus 1. So this sigma is equal to 1 minus x to the power 1 minus n. Now integrate between limits 0 and 1, we get this integration and this is equal to 1 upon n. Question 228 says that find the coefficient of x to the power 5 in the expansion of 1 plus 2x plus 3x square up to the power 4. The general term in the expansion of the given multinomial is 4 factorial upon alpha 1 factorial times alpha 2 factorial times alpha 3 factorial 1 to the power alpha 1 2x to the power alpha 2 3x square to the power alpha 3. So alpha 1, alpha 2, alpha 3 are non-negative integers satisfying the condition alpha 1 plus alpha 2 plus alpha 3 is equal to 4. For coefficient of x to the power 5, alpha 2 plus 2 alpha 3 is equal to 5, the powers of x here. Now we have two equations and three unknowns. So we need to do some trial and error. Now if alpha 2 is equal to 1, alpha 3 is equal to 2, making alpha 1 is equal to 1. If alpha 2 is equal to 3, note that alpha 2 cannot be even number because if it is even, 2 alpha 3 will become odd. Okay? And then alpha 3 will be non-integer. So alpha 2 is equal to 3, then alpha 3 would be equal to 1, making alpha 1 is equal to 0. Therefore, required coefficient is 4 factorial upon 1 factorial times 1 factorial times 2 factorial times 2 into 3 square plus 4 factorial upon 0 factorial times 3 factorial times 1 factorial 2 cube into 3 is equal to 312. Question 229 says that find the coefficient of x cube times y to the power 4 times z square in the expansion of 2x minus 3y plus 4z whole to the power 9. So similarly, the general term will be 9 factorial upon a factorial, b factorial, c factorial times 3x to the power n minus 3y to the power b, 4z to the power c. So coefficient of x to the power 3, y to the power 4, z to the power 2 means a is equal to 3, b is equal to 4, c is equal to 2. We substitute that and we arrive at the answer. Now question 230 says that find the number of terms in 2x minus 3y plus 4z to the power 100. So the general term is 9 factorial upon 8 factorial times b factorial times c factorial times 2x to the power a minus 3y to the power b, 4z to the power c. Now a plus b plus c would be 100 in the required condition. This should be 100 factorial, right? Yeah, this should be 100 factorial. That is incorrectly written as 9 factorial. Now number of terms in the expansion is number of non-negative integral solution of the above condition. So there is non-negative integral solutions for this, which is equal to 102 C100, that is 5151. So with this, we come to the end of 230 questions. Now I'll show you my website, afterworker.org, and you can download the algebra, trigonometry, and coordinate geometry from here. You can also read coordinate geometry in HTML format by clicking this link, and you will have HTML. I would recommend Firefox for reading this because Firefox has best support for MathML. So you can read the entire book here in HTML format. Okay, there is no need to download if you don't want to download it. And note that if you download the PDF, you add this date to the PDF so that after 15-30 days you come and revisit, this date would have been changed and you can download the updated PDF. I cannot put that date in the PDF because if I do that, then all existing links will become invalid. So it is practically infeasible for me. Now about the question answer website, you click the eighth link and you come to kunjika.astrotalk.org. You can join the uh, website by clicking register. And the tags for mathematics are algebra, calculus, geometry, geometry, probability, and trigonometry. And the general tag is mathematics. So you can either ask questions or you can answer questions. So the objective of this website is to build a community, and more people as they will join, we will have a solid community which can help each other. So with this, I will end this video here, and we will meet again tomorrow with 10 more problems of binomial theorems. So I'll take my leave here. You have a great day. Stay curious and keep learning, and most importantly, enjoy.